Colleen Yates, and I'm with Regional Development Australia, Perth. And today we've got a fantastic guest, Conrad Pires. He's with Pico Systems, and he's going to tell us today all about his satellites. So welcome, Conrad. Can tell us a little bit about your business?
Thanks, Colleen. So I'm a co-founder of a company called Pico Systems, and we're a small satellite solutions provider. So we're a startup, and we build small satellites, and I brought one in for you. So
oh, wow.
This is a technology demonstrator satellite that we've built,
yep.
And we hope to launch into space next year.
Fantastic.
Subject to funding. But this is it's a very simple Pico satellite, Pico meaning that that's its size. And this one here, as a technology demonstrator, so it proves what we can do, will take photos of Australia with its camera.
Oh, wow.
When it's over, and when it's flying over Australia in orbit, and we'll transmit those pictures back down to Earth, and anyone with the right receiver can receive them. So
diplomatically.
Well, look, this will only point down over Australia, and not anywhere else. Just the way it's designed, it will point over Australia. When it's up around other parts of the world, it will be pointing elsewhere. And it's almost, I guess, it's almost an outreach tool. Space is as an industry, is growing, and not many people know about what's possible. If you think of space, you think of rockets, and as cool as they are, there's a lot of many other things you can do. And where they're building is very small satellites. And when this is up in orbit, it will send the pictures down of Australia. So hopefully, when it's over Perth, it will take a photo of Perth. It will be probably from about Perth to Northam, a rectangular picture, and you'll be able to download that.
Oh, wow.
And so you'll know that, look, this has just flown over Perth, and here's a picture that it's just taken. And it's been built here in Perth as well, so it's a Western Australian thing.
Fantastic. So how do you get it up into the orbit?
Okay, so one of the great things about the space industry today is that there's a lot more options to get into space. Now, to put something into space is really expensive. It costs like around about $20,000 a kilogram.
Wow.
So this little thing here, this little small satellite, weighs around about 150 grams. So it means it's not going to cost as much to put into space. Now, what they do today, much like with Uber, you do ride sharing. You have rockets that launch a big, massive satellite that you've probably heard of in the past. These giant things that cost hundreds of millions of dollars. But there's always a little bit of space left over in the rocket, and so these little things pop on, and when they get into space, when the rocket gets into space and the big satellite's sent off to where it goes, these little things then get ejected off the rocket. So
wow.
It's ride sharing, basically.
So in terms of the technology, so you're saying the one that you'll be putting up will have a camera and we'll take a picture of Perth. Yes. What other things, because I know with smartphones we've got quite a bit of stuff that takes place on the phone.
Yep.
So the types of things that might be able to go into a satellite this size, what are some of those things?
Okay, so let me just address the smartphone comment you made there. A lot of the technology in these small satellites, and this is a very small satellite called PicoSat. You have other satellites called CubeSats, which are at 10 centimeters cubed, and then you can build them in multiples of those units. So typically what you'll see today in space, small satellite-wise, is a satellite around about the size of a loaf of bread. And a lot of the technology that's gone into that has been driven by the miniaturization of technology over the last few years. And the stuff that you find in mobile phones, often you can find that type of technology inside the phone, inside the satellites, because it's so small. So what can satellites do? In Earth orbit, so Earth orbit is when you launch a satellite and it travels around the Earth. Typically, for these small satellites, you're looking at around about 300 to 600 kilometers above the Earth. And there are sort of three things that you can do with a satellite. First is take images or pictures. It's a term called Earth observation. The second is telecommunication, so sending information up to the satellite and back down. Typically, that tends to be internet-related data today, so whether that's voice or video or just data. And you can also do positioning and location and navigation. So much like what GPS satellites do today, right? So on your phone, when you're traveling around, you switch on GPS and there's a satellite up there telling you essentially where you are. So those are the three types of things you can do with satellites. Now, our small satellites go into low Earth orbit. Satellites in general, through all sizes, are in many orbits around Earth, from very low Earth orbit, all the way out to what they call geostationary orbit, where it hovers over a particular position. So a lot of communications satellites and, say, pay television satellites stay over the geostationary orbit and will always be able to send you, for example, your pay TV, if that's what you're paying for.
So my Netflix is coming from a satellite?
Netflix is actually coming from the internet. The internet's quite an amazing thing, and satellites are one means of communicating. Now, in low Earth orbit, we can do those three things: so Earth observation, telecommunications, and positioning and navigation. So those are the three general types of things you can do with a satellite. This one here, with our technology demonstrator, has a camera. So that's a 2 megapixel camera in there. And you can see here that we have measuring tape. Now you're probably wondering why we've put that there. And it's not just for scale, though you can see that this is 5 centimeters cubed from the measuring tape. The measuring tape's made out of metal, and this is our antenna.
Oh,
right?
wow.
So why is it made out of metal? Well, you can fold up this measuring tape, or this antenna, and when you put it into a little deployer on your rocket, it sits like that. And then when it gets to the right place in space and it pops out of the rocket, it gets shot out like that, and the antenna expands. Wow. So this is a very simple way of expanding your antenna, and it's unlikely to fail because it's just physics. It's just it's just unfolding.
Who would have thought that measuring tape, the technology around a measuring tape to make it work, is actually applicable to space technology?
Absolutely. We try to be as innovative as possible, and being innovative doesn't necessarily mean high tech. So with this, but you'll find a lot of small satellites make use of this type of antenna, just because it's really functional and you can fold it right up.
Wow.
We actually have a video of our satellite being deployed in zero gravity. Now we have a relationship with ICRA, the International Centre for Radio Astronomy Research here in Perth, and what we did with them, or rather what they did with us, was they took this little satellite, or another version of this, onto a zero gravity flight with the European Space Agency last year. Now, a zero gravity flight is when you get into a plane. Typically, the plane is said to be about the size of, say, a 737, and the plane flies in the air in arcs, and on its way down, when it's flying downwards, you're almost falling inside, so everything becomes weightless. And so you've got about 20 seconds to make use of that weightlessness. So we had built a little deployer that would simulate what would be on a rocket, put this into our deployer, right, and there was a door on there, and we had an ICRA research scientist take that on board, and there's some video that you can find online that shows the door opening and this being ejected off out of the deployer, antenna opening, and then floating in zero gravity. So essentially, what would happen in space, we've tested that. So that was quite a lot of fun. Unfortunately, we weren't there, but to get that video back and to see how our deployer worked and how the satellite actually deploys into space was quite a good thing, and sort of a validation of some of the work that we've been doing.
Yeah. So basically testing what you've put together. So I understand that you've won Innovator of the Year. Can you tell us a little bit about that?
Yes, we were very surprised and obviously grateful to win. We won the Woodside Oil and Gas Encouragement Award, which is one of the awards at last year's 2017 Innovator of the Year. And that gave us, I guess, our first bit of funding, which was $10,000. So we've put that into expanding our innovation and trying to improve on what we already have here with our technology demonstrator.
Great. So tell me a little bit about what it's like being a startup, because I know that a lot of people have heard about startups and it's a bit of a buzzword.
Yeah.
So yeah, tell us a little bit about that.
Okay, so I guess we're a technology startup, but in reality we're no different from any other startup. We just happen to be working in space, and it's fun, but it's a lot of hard work.
I bet.
And it's what we expected. So from the space aspect, we were once told by someone in the space industry from the US that we were in the wrong place to do anything to do with space, because Perth is pretty much far away from anywhere. But that doesn't matter, right? Space is global. And
Space is everywhere.
it's everywhere. And the space industry in Australia is actually growing. So as a startup, we're part of that new space industry that's emerging in Australia. And so it's exciting from a startup perspective, in that it's not a completely established industry, but as it grows and as it evolves, we're part of it, so we get to grow with that as well. So I guess that's an interesting aspect of being a startup. With regards to the actual, I guess, the hard work, it's just what you do with a startup in general, and that is we have a vision. Our vision is that we want to make space accessible and affordable to everyone, and with something as small as this, which is cheaper to launch into space and cheaper to build, we're on our way to doing that. We are we are verifying the problem that we're solving for our customer. So with a startup, while it's great to have great ideas, you want to be solving a problem that a customer has. So there are two areas we're looking at the moment, and one in particular is low-cost telecommunications that we'll be able to provide with our small satellites. Preferably here in Western Australia, given that we're such a large state with a lot of empty space, and there's a lot of things happening in Western Australia from a resources perspective, both mining and oil and gas. So we're in the process of validating one of our ideas as to providing low-cost telecommunications. So things like machine-to-machine communication, and there's another buzzword flying around, the Internet of Things, or IoT.
Yeah.
So we're looking at those things at the moment. So that's the customer problem that we are trying to solve. Now you have to solve a customer problem, because otherwise no one's going to pay for your idea. And then with the startup, the other thing we're doing is we're working on building relationships here in Western Australia and around the world. Those relationships are really important, because while we can build this, a lot of the, I guess, technology and a lot of the related services and activities are things that we will obtain from third parties. So to have those relationships there,
Right.
and to understand the other innovations that are out there that we can make use of in order to get this into space, and to have a working solution for our customer is really important. So we're working on those, building those relationships, and as I mentioned, we have one with one of those relationships is with the International Centre for Radio Astronomy here in Perth, and as I mentioned, we had that zero gravity flight, which is pretty cool. But we have a lot of relationships with other startups, with other organisations in the space industry in Western Australia, and more recently we've been working on building relationships overseas as well, to make use of innovation that's around everywhere.
Fantastic. So RDA, one of the things we're working on currently is that we're putting together the business case for a drone hub here just outside of Perth. And so some of the technology that you're talking about, I think, has a nice fit in the drone space. So satellites are a little bit like drones,
Yes.
but much further up, and you don't have a remote control in terms of managing it. So with what you're doing, what are some of those things that might be transferable across over into the drone space?
Okay, so you're right. This is similar to drones, except the battery probably lasts a little bit longer.
Yeah.
Albeit it's recharged by the
Is it solar?
solar panels
Oh, wow.
there. We've only got solar panels on one side of this tech demonstrator at the moment, but the actual satellite will be covered
Yeah.
with solar panels. So we don't have to keep going and recharging because we've got the sun there, and as it orbits the Earth, it's constantly being recharged. But there are parallels there, and I think drones are a pretty amazing thing. Two things I can think of. So the first is with some of the solutions we're looking at, rather than just providing a space-only solution from a satellite, there's the ability to provide a layered solution. So perhaps we can, if we're looking at Earth observation and taking images, for example, let's just say pipelines. There's a lot of pipelines in Western Australia, and we want to monitor those and make sure that they're not leaking or they're not damaged or the like.
Yep.
With a satellite, you can take an image, and perhaps once you've taken that image, if you want to investigate at a much closer level, you can send a drone out, rather than sending a drone out and just scanning the whole pipeline. So there's an ability there to combine those two into a layered solution that will benefit the customer. The second part is with drone technology, we can test our satellite technology.
Ah,
Right?
yes.
I mean, this is small enough to put into a drone. This is our antenna with our radio transceiver inside. We can essentially put this on a drone and fly it in the air and essentially validate that our satellite can work, albeit only maybe a few hundred meters in the air as opposed to a few hundred kilometers. But still, that's a really good validation of our technology. So I really like drones.
Fantastic. And I've got an unusual question. I understand that there's a lot of space debris up there. I've got an app that's called Skyview, and it actually not only shows you the planets and constellations, it actually shows you all the space debris that exists.
Yes.
So with satellites getting much smaller, how is that going to assist with that particular problem? I do know there's people out there that are trying to figure out ways to actually get rid of the debris.
Yes.
But if we're putting more satellites up, and I think it sounds good that they're sharing rockets because that's part of the problem, are the rocket launchers. Will this assist with that particular problem that people aren't really quite aware of, space debris?
Space debris. So yeah, space debris is a problem, and so let me tell you about one advantage of the small satellites, and that is small satellites are in low Earth orbit. So low Earth orbit, 300 to 600 kilometers, right? So up there still is a little bit of atmosphere. You can't breathe it, but there are molecules of oxygen and other gases up there. And as this satellite orbits in low atmosphere, they're hitting the satellite, slowing it down. Right? If you read about the International Space Station, which is I think it's about like 400 odd kilometers up in space, they constantly have to reboost its altitude because it's being slowed down by drag, by these little particles of gas that are up there. So in low Earth orbit, these satellites will eventually fall back to Earth and burn up.
Brilliant.
Anywhere, depending on the height, anywhere from a few years to maybe 10 to 20 years. So there's a built-in, just by physics, there's a built-in capability for these to be deorbited. What we will do with our satellite is we will increase the surface area of this by adding some material across the antenna, just to bring this down a lot quicker. Oh, right. So generally in low Earth orbit, smaller satellites are going to fall out of the orbit and burn up, as opposed to a lot of the other satellites that when their life ends, they just hang around, and if they happen to smack into something else, you're going to get a lot of debris. So that's one advantage of small satellites. With debris itself, so there's a lot of international work going on to address the problem. So at an international level, at an international treaty level, there's things happening, discussions going on, and that at a, I guess at a research level and at a commercial level, there are attempts to I guess get rid of space debris. So I think it was just recently, I think it was the University of Surrey was involved in the launching of a satellite that will actually test some techniques to bring back or get rid of space debris. And I think that satellite that's been launched has got a harpoon on it, which will fire out at another. I think ultimately they're aiming at firing at another satellite and then reeling it back in and then bringing it back down. And I think it also has a net as well. So they're testing a number of technologies to potentially address the situation.
Fantastic.
Yeah.
It's so interesting because you would think, oh, yeah, things just get shot up into the air and they're not a problem, but it's almost similar to the situation that we've got with plastic, in the oceans. We're going to have to, that's going to have to be something we're going to deal with.
Yeah.
So, you've got your satellite. Is there anything else that you're working on?
Well, this satellite here is our technology demonstrator. It's show the antenna again, and if I put it in the right direction so you can actually see the measurements. So this is 5 centimeters cubed, and this is 1 unit. What we're working on is actually a 3-unit.
Oh, right. Okay.
Pico Satellite. This is our technology demonstrator. So it was the smallest thing we could build, and as a startup for the cheapest price to actually test our technology. But from a commercial perspective, we'll be building a slightly larger Pico Satellite, which is about 15 centimeters by 5 centimeters cubed, as we can fit more gear inside.
Yep.
And so that's what we're working on at the moment, along with validating our business model.
So have you had interest? I know that you've spoken about the relationship that you've got with the space group, but is there anybody else in other businesses that are interested in what you're doing?
I'd say yes, and we're speaking to companies, different types of companies.
Are they Australian or global? Or?
Well, one of the things we're doing, so as a startup, what problem do we solve? So we're, and yes, space is global, but we're looking in our own backyard.
Yeah.
So we're looking at the resources industry initially, and speaking to companies in that area to see how we can potentially be of service to them. So that's probably one of the first things that we're doing. I am talking to other companies, other types of companies in other industries, but we're starting off at least with in our own backyard.
Fantastic. And in terms of communication, I know that across Western Australia, the remoteness that we've got, oftentimes things like internet or telecommunications isn't so simple. And everybody, with the rollout of the NBN, had hoped that would actually address some of those issues, but the issues still exist. How can satellite technology in remote areas actually assist with that particular problem?
Okay, so I think satellite technology, it's both a standalone solution, but it's also a complementary solution. So you may have some cable running out to some remote towns, and you may have your mobile phone base stations and the like. But if you're in the middle of, say you're in the middle of nowhere, drilling to verify the minerals that are there before perhaps creating a mine.
Yeah.
How do you get that information from nowhere, from the middle of nowhere, back to your company to verify what you've found? One of the ways they do that today is storing that information on hard drives or USB drives, and then taking them back to the office, and then giving that to the experts and giving the experts to verify what potentially they may have found. So with the small satellite and with what we're looking at, potentially you'll be able to transmit that information in real time.
Oh, wow.
Back to your office. And what we're looking at is, we're not looking at large amounts of information, so we're not sending video back. You're going to be sending small amounts of information back, meaning that it's a low amount of bandwidth needed from this satellite, and a small amount of information being sent backwards, or back to, say, your office. which means it's generally going to be of a lower cost. So that's an example of how satellites could, or small satellites could help in remote areas.
So is that, does that open the door, for instance, with private companies actually having their own satellites up in orbit? Or is it, I'm just trying to get my head around, if we've got these small satellites and let's say that you've got a resource company and will they then be able to have their own satellite up there, or is it still a shared resource?
Yeah, so I'd like everyone to buy their own satellite, and lots of them. That would be fantastic for me. But I think what you'll find will be the best solution would be that we provide a service of saying to a customer, we can get your information from A to B for a cost-effective price, and that's all they're interested in.
Okay.
And so we take care of putting that satellite system into space, or I say system, I'd say constellation. So the way this would work is you'd have maybe 100 of these in orbit, providing constant coverage over the Earth. So we take care of that, and then you'd have this essentially a shared resource, which could then be made use of by, I guess, many companies.
Right. Okay. Fantastic. So with this, so you've got the camera and you've got the telecommunications. What else can be in that?
Okay, so one of the things I guess I'm really fascinated by is using these little satellites in deep space.
In deep space?
In deep space. So far we've been talking about satellites in Earth orbit, and I mentioned taking pictures, doing telecommunications, and finding where you are as three main things that happen with satellites in Earth orbit. But there's a possibility of sending these way out into space. One of the things that I'm pretty interested in is asteroid mining, or off-world mining.
Yep.
And there's been a little bit of that in the media in recent times. So, are we able to send these out to a small satellite, to a small asteroid, or to somewhere else, and do something with it? So, for example, we have a special sensor on board that can analyze what's on the rock, what's on the asteroid.
Right.
Perhaps these won't go out by themselves, but they'll be part of a mothership, so a bigger satellite that has a bunch of these on board. And when it gets to the asteroid, these pop off and do a bunch of things. So that's something that's really exciting.
It's getting very Star Trek-y.
It is. But I think that's sometime down in the future. I'd like to think sooner rather than later.
Yep.
But of course, with off-world mining, it'll all come down to the economics of, is it cost effective to do it? And if it is, then it'll happen.
Because asteroids, there are a number of different materials floating.
Yes.
So we'll be mining space.
Yeah. And I think what will happen there is you read articles about, this asteroid is so full of, this really good mineral that if we bring it back to Earth, it will just destroy the economy, the commodities market for that material, because there'll be just so much of it. But I think one of the first uses for asteroid mining will be to make use of those resources in space. So one example is there's likely to be water on some of these asteroids. So what you can do is if you can get a system out there to land on that asteroid and to process that water and extract it, potentially you can use that water as fuel. So you can imagine
hydrogen economy.
Potentially, yeah. Or better, I think there are thrusters out there that just heat the water up into vapor and shoot it out. So very simple. So you've now got a refueling station in the middle of nowhere, and you don't have to take the fuel with you to get there. So that's, I think that's one immediate use of materials that we find in space on asteroids, is to use them in situ.
Wow. Well, Conrad, thank you so much, and I hope all of you have found this conversation just as interesting as I have in terms of space mining and satellites and communications. And so thank you very much. And this is Colleen Yates with Regional Development Australia Perth. And don't forget to subscribe. Thank you.
Thank you, Colleen.